Hey guys, welcome back. Linear regression. I'm going to teach you guys how to do a hypothesis test when given a computer output. So let's get to it. So every hypothesis test has 5 steps, and I know that we usually do hypothesis as our first step, but in this video I'm just going to do the conditions. The conditions first, rather. The conditions are the same as they are for the linear regression. So your conditions would be the scatter plot is somewhat linear, the residual plot doesn't show a pattern, and the data is random. So I hope everybody was able to watch the confidence interval for linear regression video. So I'm going to call this step 1, and you can just put it as step 2 when you write it down. Okay, so the scatter plot is somewhat linear, the residual plot doesn't show a pattern, and the data is random. Okay. So what are we actually testing when we do a hypothesis test for linear regression? Well, what we are actually doing here is we're saying there is no linear relationship between the two variables. And obviously you have to write it in context. So in the problem that we had before, when we were talking about, when we did the confidence interval video, the two variable was brain weight and body weight. And I can't recall just yet which one was the x and which one is the y. But basically, there is no linear relationship between the two variables. Okay, so brain weight and body weight. And HA is there is a linear relationship between the two variables. Okay, well, what does that actually mean? Well, this really says beta is equal to 0. And you should do that. You should put in parentheses. Beta does not equal to 0. Because just think about it really quickly. If you draw a scatter plot and it looks like this, then our line of best fit will have a slope of 0. There's no linear relationship between the two. Versus if it looked like this, then our scatter plot would have somewhat of a linear relationship, right? So no, null. There is no linear relationship. HA is there is a linear relationship, okay? There is a linear relationship. HA, A, okay? So that's beta equals 0. Beta does not equal 0. Remind yourselves that beta is the parameter for the slope, just like x bar and mu. Mu is the parameter for x bar, okay? So beta, we're going to set equal to 0. That's going to help us for step 3, which is our formula. So step 1 is the condition. Step 2 is the hypothesis. Okay, there is no linear relationship. There is a linear relationship, always in context, guys, between two variables. Every hypothesis test has the same exact formula, statistic minus parameter divided by the standard deviation of the statistic. Well, in this case, our statistic, which is our sample, is this b here, and our parameter is beta, and then we have this standard error here. This actually gets reduced to this because in step 2, we are going to make the beta equal to 0. We're assuming HO is true. So that's why this guy goes, and this is our basic formula. This actually looks really familiar, these two values, when you think about the confidence interval problem that we did, right? So let's take a look at it. So this is the formula. T equals sample slope over the standard error. I went back and I got the question that we did the confidence interval on. If you guys recall, anytime you're doing a confidence interval or a hypothesis test, we are going to cross off the entire first line because that line belongs to the y-intercept. So that guy gotta go. I'm not looking anywhere there, okay? Now, this guy, let's get a highlighter, sorry. This guy here is the slope, okay? And this guy here is the standard error. Our formula just said t is equal to slope over standard error. So in order to find the t value, all you got to do is take the first number and divide it by the second number. If you actually took out a calculator and did this, you would get the third number. Okay, that's positive 8.379. If you know anything about the normal distribution, when a t value is anything above, let's say, 4, we know the probability, or below, negative 4, you're going to get 0, okay, as our area. But this is our p-value, okay? So 2pt greater than 8.379 is equal to 0. For those who don't understand what I did here, a couple of things. We're looking for the p-value. It's a two-sided test, so I have to put the 2 here. And my t is positive, so I need my arrow to be greater than. And once again, if you took out your calculator and did 1.096 divided by 0.1308, you'll get this number here with a p-value of this. Well, that p-value is so small, it's less than any conventional alpha. So we reject, I was using the voice recognition. We reject HO, okay? We have sufficient, chow, we reject chow. We have sufficient evidence that suggests the body weight and brain are linearly related. I think I should start checking what I write down before I just post it. Anyway, so the p-value is less than alpha. We reject HO. We have sufficient evidence that suggests that the two variables are linearly related. And that's how you do it. Okay, so it's going to be the last time I'm going to run through this. You can stop the video if you're tired of me, but first number divided by second number equals the third number and gives you a p-value of the fourth number. And that's all we have to do in order to run the hypothesis. Hope you guys had fun.